A father has 17 horses. He gives half of them to his first son, two-thirds of what is left to the second, and two-thirds of what is left of that to his third son. How? Can you tell how many horses each son gets? Let me explain the solution now. The immediate thought comes to mind after reading puzzle is that this question is unanswerable. As of course, you cannot divide 17 horses evenly by 2. Additionally, it becomes clear that after the horses are distributed, there will be some amount of horse left over, as the third brother only receives two-thirds of the horses left. So we must think carefully about the right way to solve this puzzle. One approach to solve the problem is like this. In this approach, what is important is the ratio of number of horses from one brother to the other with no horses left over. According to the puzzle, the first brother receives half of all the horses. The second brother receives two-thirds of the remaining half, which is one-third of all the horses. The last brother receives two-thirds of the remaining one-sixth, which is one-ninth of all the horses, and which leaves 1/18th of all the horses undistributed. Working under the assumption that all of the horses were meant to be given to the brothers, we can ignore that 1/18th and just compare the relative amounts that the brothers receive. This approach may be confusing. The best approach to solve this riddle is just consider a imaginary horse and you merge imaginary horse into that 17 to make it 18, an even number. Now distribute these 18 horses according to the question. So the first son gets half of the total horses, thus he gets half multiplied with 18, which is equal to 9 horses. Total horses remaining is 18 minus 9 equals 9. Now two-thirds of the horses left are obtained by the second son. That is 2 over 3 multiplied with 9, which is equal to 6 horses. So total horses remaining now is 18 minus 9 minus 6, which is equal to 3. Now the third son gets two-thirds of the remaining horses. So he gets 2 over 3 multiplied with 3, which is equal to 2 horses. Finally, total horses remaining is 18 minus 9 minus 6 minus 2, which is equal to 1 horse. Remaining horse is your imaginary horse. You can just ignore. So the first son gets 9 horses, the second one gets 6 horses, and the third son gets 2 horses, all because of adding your own imaginary horse. So by following this trick, this puzzle can be solved easily with all conditions satisfied. A farmer has many goats and chickens. There are total 20 heads and 76 legs. How many goats and how many chickens does the farmer has? Let me repeat the puzzle. A farmer has many goats and chickens. There are total 20 heads and 76 legs. How many goats and how many chickens does the farmer has? This is a math puzzle. Correct method to solve these kind of puzzle is through creating equations. As per the puzzle, we know total number of heads are 20, total number of legs are 76. Let the number of goats be x and let the number of chickens be y. So each of them have one head and each chicken has two legs, whereas each goat have four legs. So total number of heads is heads of goats plus heads of chickens, which is equal to 20. So now the equation becomes x plus y equals 20, where x is number of goats and y is number of chickens. Also we know that from the puzzle, total number of legs is legs of goats plus legs of chickens, which is equal to 76. Now equation becomes 4 into x plus 2 into y, which is equal to 76. For x, is because x represents the goats and each goat have 4 legs. That's why it is 4x. 2y is because the y represents the number of chickens and each chicken has 2 legs. After simplifying, equation becomes 2x plus y equals 38 and call this equation 2. Now solve the equation 192 to find the value of x and y. Subtract equation 1 from equation 2. This will result in 2x plus y minus x minus y equals 38 minus 20. After solving this equation, the value of x is 18. Substitute the value of x in equation 1, value of y becomes 2. Thus x equals 18 and y equals 2, which means number of goats equals 18, number of chickens equals 2. By following these simple steps, you can find the solution to these kind of puzzles in minimal time. Out of 200 fish in an aquarium, 99% are red. How many red fishes must be removed in order to reduce at 98%? This is an amazing math puzzle. Though looks simple, it is more trickier than we think. Let me explain the solution now. Initially, we know that total number of fish given is 200 and 99% are red, 1% non-red. Since only red fish must be removed, indirectly the question says that number of non-red fish must be constant. As per the question, initially 1% of fish are non-red, that is 1 over 100 multiplied with 200, which is equal to 2. Currently, the percentage of red fish is 99% in the aquarium full of 200 fishes. So total red fish is equal to 198 and non-red fish equals 2. Let's say after removing X red fish, the percentage of red fish becomes 98%. This can be represented in the form of equation like this: 198 minus x over 200 minus x equals 98 over 100. 198 minus x represents number of red fishes in aquarium after removing x red fish. 200 minus x represents total number of fishes remains in aquarium, which includes non-red fishes as well. RHS represents the percentage what we need to achieve. So let's solve this equation. After simplification, equation becomes 50 times 198 minus 50x equals 49 times 200 minus 49x. So x equals 9900 minus 9800, which is equal to 100. So now x equals 100. So it is tough to imagine that we will have to remove 100 fishes out of 198 red fish to bring the percentage down by 1% in a total of 200 fishes. The point to be paid attention is that when we are removing the red fish from the aquarium, we are decreasing the total number of fishes in the aquarium. So had we been converting every red fish taken out to a non-red fish and kept them back in the aquarium, only converting two red fish to non-red would have brought the percentage of red fish in the aquarium down to 98%. When something is subtracted from both numerator and denominator, the overall effect on the fraction is quite small, especially if numerator and denominator are large compared to the small amount subtracted from both. In this question, if you remove two red fish out of the 198 red, the new percentage is 98.989898, which is quite close to the original 99%. In fact, when a small amount delta is subtracted from both numerator and denominator, the change in the value of the fraction is a small number new delta, and the increase in delta is proportional to the increase in new delta, which is also the decrease in the value of the fraction. Here the fraction value decreases approximately by 0.005% when we decrease the number of red fish by 1 This rate of change can be calculated by differentiating the above equation. And this is another way to solve this question. So we have to remove 100 red fish. So the number of red fish in total becomes 98%. It is quite unbelievable answer. The difference of percentage is 1, but the difference in number is 100. If 29 minus 1 equals 30, 9 minus 1 equals 10, 14 minus 1 equals 15, based on this logic, can you find the value of 11 minus 1? In order to solve this problem, one should have the knowledge on representation of numbers in Roman numerals. Roman numerals are written using 7 different letters. They are I, V, X, L, C, D and M. They represent the numbers 1, 5, 10, 50, 100, 500 and 1000. We use these 7 letters to make up thousands of others. For example, the Roman numeral for 2 is written as I. The number 12 is written as XII, which is just X plus II. If we take this a step further, the number 27 is written as XXVII, which when broken down looks like XX, which is 20, plus V, which is 5, plus II, which is 2. Summing all will result in 27. The Roman numeral for 3 is written as III, but 4 is not written in the same way. Instead, the subtractive principle is used. The number 4 is written as IV. Here we have I before V, and because the smaller number is before the larger number, we know that we have to subtract here, making IV 4. The same principle applies to the number 9, which is written as IX. Let's use the same principle to solve this math puzzle. In the first equation, Roman equivalent of 29 is XXIX, and Roman equivalent of 1 is I, and Roman equivalent of 30 is XXX. If you observe carefully here, actual subtraction is not performed. Instead, Roman numeral I, which is a second numeral, is removed from first numeral, which results in XXX, which is RHS of the equation. Similarly, in the second equation, 9 is represented as Ix and 10 is represented as X. Here again, numeral I, which is a second numeral, is removed from the first numeral, which results in X, which is RHS of the equation. And finally, in the third equation, 14 is represented as XIV and 15 is represented as XV. Here again, numeral I, which is a second numeral, is removed from first numeral, which results in XV, which is RHS of the equation. So now apply the same logic for the final equation. Roman equivalent of 11 is Xi. Now remove I from the numeral, which results in X. Thus the solution for this puzzle is X, and its equivalent decimal representation is 10. Thus the answer to this puzzle is 10. If you have the knowledge how to represent the numbers in Roman numerals, then solving this puzzle is very simple. A room has 2 exits. Door 1 empties the room in 3 minutes. Door 2 in 6 minutes. If both were open, how long would it take to empty the room? Let me repeat the problem. A room has 2 exits. Door 1 empties the room in 3 minutes. Door 2 in 6 minutes. If both were open, how long would it take to empty the room? Can you solve this problem in 10 seconds? In this video, I'm going to teach you how to approach these kind of problems and solve it in less than 10 seconds. I will explain 2 ways of approaching the problem. Let's consider the first method. According to the problem, door 1 empties the room in 3 minutes, door 2 in 6 minutes. Since door 1 takes 3 minutes to empty the room, here is how the relationship works. In 3 minutes, room gets empty. So for 1 minute, 1/3 room will get empty. Thus, door 1 can empty 1 by third of the capacity in a minute. For door 2, in 6 minutes, room gets empty. So for 1 minute, 1 by 6th room will get empty. Therefore, in 1 minute, both doors together can empty 1 by 3 plus 1 by 6, which is equal to half of the capacity. If half of the room gets empty in 1 minute, then it is obvious that it would take 2 minutes to empty the room with both doors. By following these simple steps, you can achieve the solution in minimal time. The trick with these sort of questions is to calculate how much they can do in a set common period of time, add it together and then find total time. Let's look into the second approach. In this approach, we will use the concept of LCM to find the solution. I will show you how to solve such problems without touching a pen or paper. We know that from the question, door 1 empties the room in 3 minutes, door 2 empties the room in 6 minutes. Let the volume of the room be the LCM of 3 and 6, which is equal to 6 liters. Therefore, door 1 removes 2 liters each minute, while door 2 removes 1 liter every minute. Together, they remove 3 liters each minute. Thus, time taken to empty the room equals 6 by 3, which is equal to 2 minutes. Here 6 is the total capacity and 3 is the total liters removed each minute. Thus, answer to the problem is 2 minutes. You can use any of these methods to solve the problem in less than 10 seconds. Anand has 3 daughters. His friend Ravi wants to know the ages of his daughters. Anand gives him first hint. The first hint is the product of their ages is 72. Ravi says this is not enough information. Then Anand gives him a second hint. The second hint is the sum of their ages is equal to my house number. Ravi goes out and look at the house number and tells, I still do not have enough information to determine the ages. Anand admits that Ravi cannot guess with these hints and then he gives him the third hint. The third hint is the oldest of the girls likes strawberry ice cream. Now Ravi able to guess after the third hint. Can you guess what are the ages of 3 daughters? Let's check the solution now. To start with, list out all possibilities to get 72 from product of 3 different ages. Because the first clue given is that the product of 3 daughter ages is 72. So here are all possibilities to get 72 from product of 3 different ages. Since there are multiple possibilities, it is difficult to guess the ages of 3 daughters with this specific hint. Let's check the second hint now. The second hint is the sum of their ages is equal to my house number. So we have already possibilities of product of 3 daughters age. Here are sum of their ages. We have already calculated the product. Now let's see what are the sum of their respective ages. If you carefully observe in this particular detail, all sums are unique except 14. So the age sum must have been 14. Otherwise, Ravi would have guessed the ages from hint 2 itself. So we have two possible combinations to get sum 14. That is with 2 plus 6 plus 6, which is equal to 14, and 3 plus 3 plus 8, which is equal to 14. Since there are two possibilities, it is difficult to guess the ages of 3 daughters here also. So let's check the third clue now. So the third clue says that the oldest of the girls likes strawberry ice cream, which clearly says that Anand has an oldest girl and not 2. That means the oldest daughter cannot be of 2 numbers. Hence we can rule out 2 plus 6 is equal to 14 option, because oldest daughters are 2 in this case. So the ages must be 3, 3 and 8, and that's the solution. So ages of 3 daughters are 3, 3 and 8. John started a business in which he earned $1 on the first day, $4 on the second day, $7 on the third day, $10 on the fourth day, and so on. What is his earning on day 1001? We can solve this problem by using simple math concepts. Let me explain the solution now in detail. According to the question, John started a business in which he earned $1 on the first day, $4 on the second day, $7 on the third day, $10 on the fourth day, and so on. The thing that is unique about the question is that each day his earnings increased by 3. The pattern looks like an arithmetic progression. Hence, the earning each day are in arithmetic progression where each term has a common difference, that is, difference in each consecutive term is constant. An arithmetic progression is basically a sequence of numbers such that the difference of any two successive members is a constant. For example, the sequence 1, 2, 3, 4, etc. is an arithmetic progression with common difference 1. Similarly, the sequence 3, 5, 7, 9, 11 is also an arithmetic progression with common difference 2. If the sum is s, the sum s of the first n numbers of an arithmetic progression is calculated by the formula s equals n into 2a plus n minus 1 into d divided by 2, where a is the first term in the sequence, d is the common difference between terms, and n is the nth term in the sequence. We use this formula to find the solution for this problem since the pattern looks like an arithmetic progression. In this sequence, a equals 1, which is a first term in the sequence, d equals 3, which is the common difference between terms, and n equals 1001, which is the nth term in the sequence. So now solve for a equals 1, d equals 3, n equals 1001. Substitute the value of a, d, and n in the formula n into 2a plus n minus 1 into d divided by 2. After substituting, equation becomes s equals 2 plus 3 into 1000 into 1001 divided by 2. After solving, equation becomes s equals 3002 into 1001 divided by 2. After solving this, s equals $1,502,501. Thus, total earning of John on day 1001 is $1,502,501. By using this simple math technique, you can solve this problem easily. Let xyz be a 3-digit number where x plus y plus z is not a multiple of 3. Then xyz plus yzx plus zxy is not divisible by which of the following option? The options are 3, 9, 37, x plus y plus z. Let me solve this problem step by step. To solve this problem, one must know to represent generalized form of a 3-digit number. The general form of xyz equals 100x plus 10y plus z. Similarly, the general form of yzx equals 100y plus 10z plus x. And the general form of zxy equals 100z plus 10x plus y. And call these equations as 1, 2, and 3. So now add all these 3 equations. Adding 3 equations, we will get xyz plus yzx plus zxy equals 100x plus 10y plus z plus 100y plus 10z plus x plus 100z plus 10x plus y. After solving this equation, so the result is xyz plus yzx plus zxy equals 111x plus 111y plus 111z, and call this equation as 4. Now simplify the equation 4. we will get xyz plus yzx plus zxy equals 111 into x plus y plus z. Now it is clear that 111 is the common factor. So xyz plus yzx plus zxy is divisible by 111. Also, xyz plus yzx plus zxy will be divisible by factors of 111. From the above options, 3 and 37 are factors of 111, hence these two numbers are divisible by 111. And as we can see in the last expression, x plus y plus z is also a factor of 111 into x plus y plus z. So only number which is not divisible in the given option is 9. Hence the solution to this problem is 9. See, by following these simple steps, you can solve these kind of problem in less time. How many diagonals can be drawn by joining the vertices of an octagon? Let me repeat the question. How many diagonals can be drawn by joining the vertices of an octagon? This is a pretty interesting question, and these kind of questions are usually asked in competitive exams. I will teach you like how to solve these kind of problems in less than 5 seconds. Let me explain the solution now. Octagon is 8-sided polygon. If you draw an octagon, select one vertex and construct each diagonal from this vertex. You will see there are 5 such diagonals. Thus, for each of the 8 vertices, you can draw 5 diagonals, and hence there can be 5 times 8, which equals to 40 diagonals. But remember, each diagonal is counted twice, once from each of its ends. Thus, there are 20 diagonals in a regular octagon. So to summarize, each point on the octagon can be connected to 8 minus 3 points. This is because you cannot draw diagonal by joining the adjacent vertex. Hence we need to subtract 3 vertices. So each point can form 5 diagonals. So we get 40 in all. However, this includes similar pairs, that is 1 6, 6 1, 2 4, 4 2, etc. So we divide this by 2. So answer is 20. We can generalize the solution for any polygon. If n is the number of vertices, we can derive the formula. To draw a diagonal, you have to select 2 vertices out of n. But you cannot draw diagonal by joining the adjacent vertex. Hence, number of diagonals can be calculated using the technique of combination. Number of diagonals equals nc2 minus n, where n is the number of sides of the polygon. So for octagon, n equals 8. Hence, number of diagonals equals 8c2 minus 8. So 8c2 is nothing but 8 times 7 divided by 2 times 1. So after solving this, the expression becomes 28 minus 8, which is equal to 20. There is another way which is easier compared to this technique. The number of diagonals of an n-sided polygon can also be calculated using the formula n times n minus 3 over 2. For example, in a square, there are 4 vertices. In this case, n becomes 4. Hence, after substituting, number of diagonals possible in square is 4 times 4 minus 3 over 2, which is equal to 2. Similarly, in octagon, there are 8 vertices. Hence, n is 8. After substituting, expression becomes 8 times 8 minus 3 divided by 2. After solving this expression, the solution is 20. Just remember this formula, that is n times n minus 3 over 2. You can find number of diagonals in any polygon in less than 5 seconds. One page is torn from a booklet whose pages are numbered in the usual manner, starting from the first page as 1. The sum of the numbers on the remaining pages is 195. The torn page contains which of the following numbers? Is it 5 6 or 7 8 or 9 10 or 11 12? The most important thing about solving this problem is not just finding the correct solution, but to find it in less time, because that's what it demands in most of the competitive exams. So I am going to teach you how to solve this problem in less time. First of all, it is important to know one of the most important formula to solve these kind of problems, that is sum of n natural numbers. The formula is important here because the pages in the book are marked in the form of natural numbers, that is 1, 2, 3, 4, etc. We know that the sum of all the numbers from 1 to n can be calculated by using the formula n into n plus 1 divided by 2, where n is the last number in the series. Remember, this formula is applicable for only positive natural numbers. For example, sum of first 10 natural numbers is calculated like this, that is 10 into 10 plus 1 divided by 2, which results in 55. In this case, n equals 10. Let's come back to the problem. Since page numbers are represented in the form of natural number series, without doubt, sum of all page numbers including torn page must be greater than 195. Now the task is to substitute for value of n till we get the number which is greater than 195. Now pick some random numbers. For example, first consider n equals 15. Sum of first 15 natural numbers is 15 into 16 divided by 2. This is after applying the formula n into n plus 1 divided by 2, which is 120 after solving. Since 120 is less than 195, we have to choose the other number which is coming close to 195 and it should be greater. So now consider n equals 20, which will result in 20 into 21 divided by 2. This equals to 210. This can be a right number which we are looking for, because for n equals 19, sum results in 190, which is less than 195. Hence 19 must be rejected. Thus, number of pages in the book is 20, and now the task is to find the torn page. So now we need to subtract 195 from 210, which results in 15. So what are the two consecutive numbers those sum will result in 15? They are nothing but 7 and 8. Thus, answer to the problem is 7 and 8. This is the approach one must follow to find the solution to these kind of problems. So I will show you one more problem which requires similar logic. So the question reads like this. We are given a series of numbers which contains integers from 1 to 50, including both 1 and 50. However, the numbers are in a jumbled form, that is, they are not arranged in increasing or decreasing order, and there is one integer missing. You have to identify the missing integer. How will you find? Let me explain the solution. We know that the sum of all the numbers from 1 to n can be calculated by using the formula n into n plus 1 divided by 2, where n is the last number in the series. In this case, n is 50. So therefore, sum of all the numbers from 1 to 50 is 50 into 51 divided by 2. After solving, sum of all numbers from 1 to 50 is 1275. Therefore, all we need to do is to sum all the integers present in the given series and subtract the sum from 1275. So this is the same procedure that we followed for the previous problem as well. So the difference between 1275 and this sum would give us the missing integer, because 1275 is sum of natural numbers from 1 to 50 and this number is sum of natural numbers from 1 to 50 without including missing number. Hence, subtracting the sum of given series from 1275 will fetch the missing number. So this is the logic to be used to find the missing number in the given series, provided that the series is positive natural numbers. And this is the logic to be applied in order to solve these kind of problems.